Hey, now we're live. So, hey guys, this is Jan from DoraHacks, and welcome to our third Polygon DevX American Hackathon workshop series. And before we start, let me introduce briefly the background of this hackathon. As the largest Web3 multi-chain developer incentive platform, it is an honor for DoraHacks to support the Polygon DevX America Hackathon, and we supported the APEC and EMEA series, and now we're doing the America series. We're looking forward to all the amazing projects building on top of Polygon, and today we're happy to have Joshua from Phala Network to do a workshop which is about building cross-chain with Phala. So without further ado, welcome Joshua to start. And for all the questions, if you have like any kind of question during the session, feel free to drop them in the YouTube and Binance live chat. And Joshua, like feel free to start when you're ready.
Okay. Hello, everybody. My name is Joshua. I'm the Director of Tech Evangelism at Phala Network. Today, I'm going to show you how to build like a cross-chain application utilizing Phala's FAT contracts, which allows you to program in JavaScript and get access to any API. And then you're able to then anchor to a on-chain smart contract. In this case today, we'll be using Polygon ZK UVM to be able to pull this consumer contract on the Polygon ZK UVM chain. And whenever there's a request for an action to be fulfilled, that contract will then go and do some work based on your custom configurable logic in the JavaScript script. And then from there, it'll return an action reply back to your chain so that you can consume the data that you have requested for off-chain. So this is some other things here. We have a Phala Network logo here. You can find us at Phala Network on X and I believe phalanetwork.lens as well. I think we have another QR code because I don't. Anyways, so I'll just go straight to these prizes as well, just to kind of show you what we have for our types of prizes. So we're really looking for some creative and inspiring types of projects. In this case, something that you feel like you've probably never been able to do, or you didn't do because maybe you had no access to this off-chain data, and maybe from there you weren't able to do any kind of complex computation on top of that. So what we are like really looking being way outside of the box and trying to like go and reach for that really cool idea that they haven't done before. And the second types of prizes that we're looking at is also the Web3 social integrations. So Lens protocol in this case, being able to use the Lens API from your FAT contract, which I can show you some of the code here, and also in our hackathon page, we also have an example of the Lens API oracle that we created recently with the starter kit. But from there, you can incentivize your community by creating different types of games, or incentivizing your followers to mirror your posts, and maybe based on the promotion of your from your fans or from your community in general, you can reward them for doing great work. There's also plenty of other aspects that I could probably go on all day about, but I'll also then kind of move to the next one, which is qualifying submissions. So qualifying submissions would classify as a complete project that has deviated away from the standard template in our starter kit. So there's a starter kit repo in our GitHub, and from there you can get started really quick and deploy your cross-chain application really fast on the Polygon proof of stake network. So you can try that out, and you can even test it locally. But if you submit that won't qualify as like a qualifying submission. Just to make that clear for everybody here. We also want to note that we have like videos, blog posts, starter kits that you may want to build if you don't have time to build out a creative idea. These are some pretty good ones where you can get some Phala tokens and some merch in this case, and we'll promote you, and also really look forward to kind of like hearing your thoughts and seeing your experience through your videos, your blog post, or even creating starter kits for people that have that haven't have like a type template that they have they're like used to developing on in this case. But yeah, anyways, I'm gonna go into the demo like workshop. But are there any questions to start off?
So far, there's none. So let's start off.
Okay, so what I'm gonna do here is I'm gonna show you the DoraHacks page, just because this is the typical developer journey when they come in here and they see all these bounties. They go through all these, and if you go down towards the bottom, below Rally Protocol, you'll see Phala Network here. So we give like a short little about here about how we're a decentralized off-chain computation protocol, and we allow developers to deploy secure off-chain programs and interoperate with other chains through HTTP requests. So you're able to then enhance your smart contracts and make them smarter in this case. But if we go down here, like I mentioned earlier, if you need some ideas on what to build, we have a few links here of some of the past hackathons that we've hosted. So this would be like a Web3 social. We had Lens Fight, which was a developer that was able to use the statistics from Lens API and generate different scores for their actions that they could use in a like a battle against another Lens profile. Then there was Safe Shift, which was a NSFW blocker on Lens, which was pretty nice. We had Just Roles for guild.xyz, so you could potentially re-implement guild.xyz through Phala with the fat contracts in this case. We had some dynamic NFTs for the trading Telegram bot we built, and then also one of the hackathon participants created this project called PokeLens. Some AI integrations. There's a link here for like Smart Cookie, and then our recent attempt at a hackathon was Small Ask, which was the intent-based architecture. And then we also have like a bonus integration. If anybody out there has worked with the subquery and worked with it on Polygon, then integration there also gets you extra bonus points, and you can get access to other prizes as well. But so as you go through here, you'll see at the bottom here the Phala Fat Contract Starter Kit. So that's where we're going to start off today. As you come here, you'll see the Fat Starter Kit. We'll go into an overview, and I've been talking a lot, right? But here's this diagram to kind of show you what we're building today. So Phala Network is its own blockchain, and you can deploy your off-chain programs called fat contracts on our chain. And from there, these contracts are written in Ink, which is Rust-based EDSL, which compiles down to WASM, and these are deployed into our runtime, where we get a contract ID and a code hash, and we're able to then also be able to make calls to custom JavaScript scripts that we can call from these like Rust-based fat contracts that we call. But the power of this is because they're running, since we're running in a secure off-chain environment, we're able then to interface with the internet and make these HTTP requests. So now we can have this request and response queue where we have this consumer contract, which is Polygon in this case. And from here, we have a off-chain rollup anchor, which is where your consumer contract and its business logic will have a user maybe that comes in that submits a new request. This new request gets popped onto the queue for actions that need to be fulfilled. The fat contract on this chain, which is yours, would be polling constant. I think every 30 seconds right now. For a new action to fulfill, it sees there's a new action, so we pop it off the queue. One of the workers takes care of it, and based on whatever logic that you put on there, like let's just say for the Lens API Oracle case, we were able to then make calls to the Lens API, and from there you're able to take that data, mutate it, do whichever complicated logic you want, and then return a response back. And you have from the time that you start your action response, in this case, you have 10 seconds to be able to return your answer back in this case. And also in this case, we have like a type of account abstraction implementation that allows you to have this be only paid on the consumer chain. So all the gas fees are on the consumer chain. The only gas fees that you would pay on Phala would be for uploading and instantiating your contract, and then anytime you want to update your script. Are there any questions for this like high level overview of the architecture?
So far, I cannot see any questions in the chat, but like if there's any questions, just put it in the chat.
Awesome. Okay, so what you'll come into here is, as you can see at the very top right here. Well, I'm not signed in, but actually I probably should do that. But whenever you are signed in, you should see this, use this template, and you can create your own template from this starter kit here. Another way is to use the command line tool called @phala_fn, and then you would create your new project. So let's, for the sake of this time, we'll do it through the command line. Zoom in. I believe it in temp. Okay, so I believe it was npx @phala/function init DevX name. So now you're going to get two options. We have the fat contract starter kit, and then we have the Lens API Oracle consumer contract, which is also the basic Lens API Oracle that we have as a template, and we'll be adding more templates here as well as we add more different use cases that you can kind of build from a boilerplate perspective. So what I'm going to do is choose the first one. And it should, okay, cool. So now I have my DevX AM. I'll do yarn install. Awesome. I guess we could look at the README. It doesn't look very nice, so maybe we can open up that editor or something. Cool. So like I was kind of going over earlier in GitHub, we have the same template. So this template's just kind of cloned and set up in your own environment. So we just completed this step here where we just created our new project. So if you were following along, congratulations. So whenever you're going through here, we kind of like give you kind of like a breaking point kind of stop and say like, oh, what exactly are we building right now? So what we're going to do real quick is show you how to locally test out your function in this case. So this function is the JavaScript file that you'll be editing so that you can run this function in a local environment and be able to test it against like an expected on-chain smart contract on a hard hat in this case. So what we've already done here is run the yarn install. So next we're gonna build the function. So what we're building here, if we go in to this index.ts file, at the top, we have like a little note here that's like you're limited to the imports to build your fat contract. So adding any other extra imports is not gonna be able to. You won't be able to successfully upload your function to the Phala network because we have to have like for instance like our JS engine that we have deployed on our chain. You can't just add other packages because that's obviously like a huge security vulnerability, and also every worker is going to have to also include these packages in their runtime as well. So you're just going to kind of bloat the chain if you keep adding more and more. So we have like a very lean JS engine here, and this can be told by here the @Phala/pink environment, which pink stands for Phala Inc. Inc is the EDSL that I mentioned earlier that is written in Rust for your fat contracts in this case. But we also have the ethers library for coders. So I put here like the ETH API coders available, just some little examples of how to use them. So that you can encode and decode your APIs for your action requests and action responses in this case, and I'll go into that a little bit later. But for anybody that feels that they need to have a doc, well, this JS API doc here, this will give you a high level of all the capabilities that you have available at your disposal. It'll kind of go into the same little getting started, but after it does the getting started, it dives straight into what your basic index.ts file, in this case, like the fetch API stats, where in this case, we're creating a GraphQL query for a profile that is passed in from the profile ID here. And then we're then getting the stats of the total followers, total following, total posts, comments, mirrors, publications, collects of a profile. And then from here, as you can see, we convert this string that we created here from the JSON stringify for query. We then hex it, and then from here, this is kind of like where we get into the more interesting parts. Is we're looking for a response, and it says pink.batch HTTP request. So the batch HTTP request allows you to create an array of up to 5 HTTP requests to be sent out. And from here, on this example, we only define one of them, and we allocate it at 0 here, so that we can make sure that we give the response the right index for the HTTP request that is being sent out. And this number here after the array of HTTP requests that you can make, this here is your timeout. So in milliseconds. So we have like 2 seconds for this to run. And remember, like I mentioned earlier, a action reply is going to allocate you at least 10 seconds. You have like up to 10 seconds to be able to complete all the work that you want to do in this script here. So So when it comes down to here, we get the response. We have a status code. You can return errors in this case, and return that error back to your consumer contract so that you know that your action was run, but it failed in this case, so that you can kind of have like you have your asset guarantees in this case for all this off-chain work that's happening off-chain from your consumer contract. So as I go down here, if you look at this further, there's the pink.invoke contract and the pink.invoke contract delegate. These two functions, they're a little more advanced. If you are comfortable writing in Rust and you want to try out the Rust SDK for a fact contract, then you can kind of you can deploy a contract and then make a call to that contract, like in these examples here, where you have the code hash, the selector, so the function that you're calling, and the input by doing a scale encoding of the inputs. I'll show what that looks like a little bit later, because what I did for the project was create a Rust SDK for interfacing with S3 buckets in this case, and then you can make your get, put, delete, and the head of a bucket in this case, and then return that information back, and then be able to then create these what we call dynamic NFTs in this case based on the weather. But if we go through here too as well, since this will be pretty quick, the pink.http request is the singular HTTP request. So earlier I mentioned the batch HTTP request. This is just, if you're only going to make a single HTTP request, it's probably the easiest way to do it. Simple little example here of getting an IP here, but there's other examples in the README as well, so that you can check out different ways to create these HTTP requests. And then mentioned here that the batch HTTP requests and all the different definitions here as well for your parameters. I did mention about how it's an array of HTTP requests. So then you have to define this value here in a box, like depending on what index your array is to your response in this case, or you can create an array of responses that can be allocated to each based on how many HTTP requests you're making. So in this example here, this is like a DApp I built called Intense Sports Ball, and what I did was I'm showing an example of doing a batch HTTP request, right? And this batch HTTP request is going to go out and it's going to go to the odds API and get all the sports scores in this case for all of the sports. So in this case, like baseball for the MLB, it'll get all the scores for them, and then it'll also like have like the betting lines for each of the games, right? And then I have the KVDB HTTP endpoint, which is a key value database that's for free. And I just wanted to post hello world there. So you can see in this KV update here, I'm just saying hello world. So those are this is the first little batch HTTP request that I'm making here. And from there, I'm then taking the response one. So in this case, this is how you can say, you can define an array that maps to each HTTP request in this case. So you have your array of HTTP requests. This matches to here. This matches to here. So what I'm doing is getting the body. I didn't show the error handling in here, but you should do error handling in this case if you don't want to see some weird errors. But so what I do is just take that response body and then I post it into a Telegram chat. So I just do a Telegram bot. I think I have the bot up, but I can. Oh yeah, I show an example. Yeah, so So here is what you would expect to see. So in this case, this is the kvdbi.io. I go to the hash that gets thrown out in the logs that I was printing out. It's not shown in here, but then I go to the link and I can see that I have the hello world. And then I go into my Intense Sports Ball Telegram group and I can see all the scores and information from that day's games. So you can kind of see this. This was before the playoffs. So you can verify if those games were played or not. So I did mention the error handling. This is kind of like the syntax of like a single HTTP request that you could do for doing the error handling. And then the next one, you can also derive secrets. So since these fat contracts are running in these secure off-chain workers, they're able to execute in essentially like a black box. So like a secure, a trusted execution environment in this case. So now we're able to offer these secrets that you can derive from your JS script in this case. So what I show here is me going to the tgbot HTTP endpoint. So I'm trying to send a secret message, and what I do is I derive a secret a little bit above, and I have this secret here. So then I pass the secret in, and this secret then I got it to post to a Telegram group that I had, so I can see the secret that gets printed out here. So this is kind of like one of the things that you have at your disposal. There's also a hash function. You can choose which algorithm you want to use. We have these supported values for like Blake 2B 256, SHA 256, and then a message as well. So you can just hash the message. So what I did here in this example, what I show you is creating every single way to hash each hello, and then I go to the kvdb update and I print it out, and then I also post it in a Telegram group. So to see those results, that's how these results ended up playing out. You can see that based on the different ones, you would have different links. So there you go. And then it goes into the handling of encoding and decoding in this case. So you want to be able to handle different responses and action requests as well. So like whenever you enter, so this is your main function in the index file here, you see. What you'll do is like you'll enter in here and you'll get this request. This request is a hex string that based on however your smart contract submits a request to the action queue. In this case, the default way is you'll have a request ID and an encoded request string, because the basic example is querying the Lens API, and you get a request ID to know the number of the request that you're taking care of, and then the encoded request string, which is the profile hex string that you'll be querying in the Lens API query. So coming from here, then you'll see this like the coders.decode, and then you have your uint coder and your bytes coder, and then the request, and this will be returned here. And then I just kind of put Mike Jones as a response and send it back for like a string response. But yeah, this just kind of give you like an idea of how this is working from a high level. And then it kind of goes into their Booleans. It gives you like examples of different like coders now. So like you have your address coder, Boolean coder, and so on and so on. And then that will be like, and then I'll go into some complex examples, but that'll be like all the things that you really need to look at first. I just wanted to go through this just so that you know that this is like a document that you can look through and be able to check out, so you can have some examples and figure out how to build out your function from the basic template. There's also secrets. This goes into the secrets here. You can store secrets in the dashboard. So in this case, we have our settings here, and this is where you would store your secrets, my super secret, my secret proof API, my API, and this is passed in here. You see like the secrets here. So that's where you can consume your secrets and then be able to use them based on your configured environment. I want to stop for like a brief moment, but does anybody have any questions currently? And then I can kind of complete the getting started piece.
So like there are no questions in the YouTube, not in the Binance Live as well. So like if anyone has a question, just like feel free to drop them and I can share the questions.
And also like if you're watching after the fact as well, just you can always reach out to me as well. Go into our Discord. We're eager to hear your feedback, and if you have any problems, we're more than happy to fix it. And see like any kind of pain points that you may have, and we'll make sure to get them settled as fast as possible. All right, so where I had looked at it for a little bit. I had installed. I did a yarn install, and we can go back to our README here and now build the function. So I went through the function. I gave a pretty long discussion about the different capabilities that you have at your disposal. So let's build the function now. So whenever you do this yarn build function, this is calling the fat function build command. You can see what they look like here in the packages, but yeah, the fat function build source / index that will result in the index.js file here, and from there we can go back. From there we can then run like the expected, like what we're expected to get locally. So what I'm going to do is I've already encoded the request ID and the request string here, and then I'm passing in the Mumbai API for the Lens API in this case. So I'll copy this and just put that here, and we'll run the function. So this will execute your function, and it'll give you a response, handle the request received for profile OX01. So we got a result already. If we take a step back and we say, well, okay, that's pretty cool, all these numbers and words, that it's pretty interesting, but what's going on here? So how this query looks is, I showed this earlier, but it's going to the Lens API. We have the profile ID 0x01, which is the first profile, and it comes back with this expected output here. In this case, I believe I used total posts, but we can go ahead and verify that by going down here into the main function, right? We have the main function. We fetch API stats here, and then we have total posts. So that shows 3. That's good. So let's maybe we can just quickly see what let's see, total following. Oh, that's not how you spell following. See if this. based on, yeah. Oh, it should be 0. I want a number. Okay, followers. Let's do followers. All right, so we'll just rebuild the function. So it's real quick. So this is if you're trying to get the proof of concept going. You're like, oh, I need to work fast. I just want to get this through. I know my expected encoded inputs. I know what API I'm hitting. So I'm just gonna pass it in, run the function. Oh, cool. I got my answer. So you know that you're getting your information. You're starting to work a little quicker, and you have something local for you to test out. Hopefully, if they're hopefully this is a good thing for you all to help enable you. And the next part of the quick start is you just run the yarn hard hat test. Cool. So this is the quick start. So we've gone through. We've run the quick little test here with the test Oracle consumer contract. Here you see that we run that built function here with the data. In this case, go down. We push and receive a message. So we're testing this from the deployed contract. So we deploy it here. We have the profile ID. We then make a request. So if we take a look at the Oracle consumer contract, there's a very important part here that is the fat rollup anchor, which is the action request queue that I keep mentioning. Here you can see if we go into that file, we'll have like a little description here, but essentially like the way that we're making this request is by push message. Yeah. So the push message is what's adding this onto the queue. So if we go to that function here, pick in some bytes of memory for your data parameter, and I'll get the tail here. Like IM key will encode the tail. We'll set the bytes. Set the UN, add 1 because we've now added a new request on the queue, admit that the message has been queued, and then we'll return tail. So that is what will kickstart. Say like our fat contract is running in the background. It sees that and says, "Oh, I need to go take care of this request." So from that part, the fat contract that's pulling on the Phala network will then go towards your that will then fulfill that action in this case. So we can easily go to the fat contracts UI. This is the other one. This is mine. So whenever you come to this dashboard, you'll have a little dashboard like this. I can actually, we have one that's in preview right now that'll be like a little more closer to what you should expect whenever you're entering our dashboard. So here's our dashboard here. I have my account. I sign a certificate. So the certificate signed. And now I have all my functions here. So I have 2 running functions right now. So this is kind of like how your dashboard would look after you deploy a fat contract. I'll show you that command here in a second. So we can go here. This configuration looks good. This is a Polygon ZK EVM testnet contract. You see I have like 0.02 ETH in it. So this gas account is going to pay for the transactions that I'm executing on the Polygon ZK EVM testnet. to make my that contract active, I have to stake behind the cluster of workers, because whenever you have a contract uploaded and instantiated on the network, you have to stake some Phala behind that contract so that it can become active. If not, then your contract won't have enough compute resources from the cluster to be able to perform any tasks for you. So if we go into this configuration area, we also have this attester address. This attester address is very important because this is what you will set in your consumer contract as the attester address. So if we go back here, we see a tester role. Okay, so a tester role is here in the constructor, but you will in this like environment.local file, you'll define that here. But even whenever you're right here, even whenever you're run a command locally, it'll ask you to set this Oracle attester as well. But just to kind of show that and then show where it is in the code, but this allows this address to make the call, and then the gas account pays for the gas to execute the transaction. So kind of like the paymaster in this case. So here I put a random quote, and this is my client. So the client here is your smart contract. So we can go onto ZK EVM's chain. So these are some of the things I did like 9 days ago, but I created a dApp that was able to, it was able to interact with, allow to have it like the Polygon ID gated access with the verified credentials. I used that template, and then the contract, whenever someone incremented the counter, it then added an action request on the queue, so that if we go into this, if we go into the logs, if it is in there. Oh yeah, so you can see like whenever it went and got the random quote from the API, it just says computers are useless. They can only give you answers, Pablo Picasso. So these are it was just answering off a little simple increment, but these are the kind of things that you can easily just put into your consumer contract so that you get access to this off-chain data, or make cross-chain interactions, or maybe like interact with other chains, right? So you can do something pretty complicated and creative in this case. So this is like kind of what you should expect. And then you have here, it's like, do you want to update this from the command line? So like you have your deployed contract, and if you run this command here, this command will based on like your code in the, let's see, like based on this code, if you modified it, you built it, and you're happy with the local test that you've done, and you think it's your code's ready for an upgrade, then you can push that upgrade with I believe this is like the syntax yarn like in this case it would be test function or test update function. Yeah, so update function. And then you're able to then run through the, I believe it's like, yeah, it'll ask for your workflow ID. I haven't deployed anything yet, so I'll put 0, substrate URI. So like in this case, I'll put Alex, but you could also add your, there's like a little tutorial on how to like add your JSON file to this directory for your substrate based address. And then you can just put a password in whenever you're doing this this little piece. But see, it should fail because it doesn't exist, right? So I haven't deployed yet. But we could, well, need to do something else before I do that. But anywho, since we've gotten through like most of it, are there any questions right now? And what's the I forgot what the time limit is on this tutorial, because there's a
So far, there's like no questions. I feel like it has been super insightful, a lot of technical information. And we do have like a few minutes more. So like, if you want to show a bit more, that's fine. And if not, we can also like give the audience some more time to digest and come up with questions.
Oh yeah, awesome. Yeah, so I guess then I can kind of show what I've been building so far, because I'm building a little dynamic NFT example that so for instance, this is my my weather mojo. So this is my little dog that I create pictures of because it's pretty funny on Midjourney. And essentially what I'm going to do is get information from weather, which is we can so like this is like a weather report, right? But they have like some cool functionality where you can like kind of format it in a way that already formats it into a like NFT metadata, like a token URI format. So what I've done is in my index file here, I've where is it at? So first I do the get weather right here, and then I have like an output format. This output format formats it in the way that I need it, so that whenever I make a get, I get it in the format that I need, right? So whenever I return from this function down here, from here, there's a symbol whenever I execute, and this is if I go here, it's like get IPFS image, and this is all within the script. So this is running inside the trusted execution environment in this case. But I translate the symbol because these symbols here, that's what these are based on the weather, and based on what this symbol is, it'll change what the media URI is, the image URI. So in this case, sun's out, he's hanging out. This is whenever it's sunny outside, right? The other one could be it's cloudy, but he's off for sale. And then it's raining outside. You know, he has to have his jacket. And then ultimately, the rare events of snow, he's just kind of clothed up. But the interesting part isn't just returning that as back to the contract. The real interesting part is I can interact with the Rust SDK contract, and if I can load that up. I think it was in. So what I'm doing essentially is I'm able to interact with the S3 bucket on Foreverland. So in this, like for example, I already done this, but endpoint for Everland co US plus it. Let's see. I think I did maybe Dallas weather.json. This is weather module. Should be able to run. Yeah. So so that's the kind of like the power. Everything is executing in queries. So you're connected to the worker. You interact with your contract directly, and it executes through a query, and it replies with your information, your update, like as soon as possible, like this, right? So this is kind of the body of like what the JSON file looks like. If we want to check that out before the time closes. Actually, I don't think that's it. Let's just go to forever then. Essentially, it'll be like this. So since they have like a URL that you can for your bucket, I think it should look like this here. So this is like me querying the weather API. I'm able to then format it right away with like the name Dallas as the city, description, weather in Dallas, external, which is this link here, the image, which I showed earlier, the attributes. So the attributes like for like OpenSea, if you want to have these attributes update like your timestamp of that day's timestamp, the trait, which is the city, Dallas, and then the value of the weather that day, which is light rain. And then you would take this information however you would like it, and then send it back, and then you would go into your third web here. Like, so in this case, you would then add your consumer contract as a minter, and from there, whenever you get your on message received, so whenever your FAT contract is replying back to your consumer contract, you can come in here, you see that you can do your custom logic here, and then you can go and try to mint the token. In this case, I was trying to just do it basic ad hoc with the owner address, and then waiting to do this a little bit later. But and then you get like you can mint your NFTs in this case. I did a similar one with a lens treasure hunt where you queried all of the profiles on lens. You selected one. If you dig that profile, you can dig it for gold, and if you got a number between 1 through 5, and it was the NFT ID 0, then you get a piece of the treasure at the end when all of the NFT ID 0s are minted in this case. But yeah, that's kind of like how it would look. But I think I'm over, so I just want to be nice about time. I could probably go on forever.
That's super cool. Great job. And maybe you can also like share a bit more about the bounties. Like at the beginning of your workshop, you shared a bit about the bounties, but it would be good if you could share with the audience what you would want to see that's getting built, and maybe share some tips.
Okay. Yeah. Let's see. I think so. We have these. I'll go to the DoraHacks page. It's better. Yeah, so we're under Rally protocol, but we're here with Phala Network. $10,000 in prizes. We have two prizes that can get the $2,000 reward by creating a very creative or just really reaching out there to build something that's never been seen before, or people may see it and think it's centralized, but in this case you can really embrace like the decentralization of our protocol, and also show that it is possible to get speed and like a highly secure with like privacy by default type of programs running alongside your on-chain smart contract in this case, to create something a little more unique. Second prizes, we have 3 prizes up to for 1,000 each to do a Web3 social integration. There's a ton of really interesting like APIs out there as well. I think one's like there's like Airstack. Airstack has like a really good set of APIs out there that you can use, and then you can start using multiple Web3 socials, and then say you want to then maybe like also extend it to Web2 socials, and then you just kind of combine all this information into one platform so that you can create some kind of score to like incentivize people's communities and people that are like promoting, and you can verify that on the platform and bring that back on chain so that you can pay out some rewards, or even just like create some cool like rare NFTs. So like maybe like how like Taylor Swift does her like her records like drops randomly in some random record store. It's like really rare, but you can kind of like involve your community in very unique ways in this case, now that you can kind of extend to all these external APIs now. And then the other 3 were up to 5 prizes for each. You get some Phala tokens. We really want to incentivize some people to build out some of these fat contract starter kits, kind of based off of the original starter kit, kind of take that template and make it for something in a different area. That would be really nice. And you can win if you make multiple that are very high quality. You can win multiple of the starter kits. At least that's from my thinking. But also like videos and blog posts for people that may not have the time. They just want to learn. I'm happy to help you with any information verifications. Don't put in ChatGPT and put an article out there, because there's a lot of stuff that's wrong. But yeah, that's probably some of the ways to get some prizes. And then like honestly, like I even be willing, if there's people that are interested in setting up like a little like spaces or a call in Discord, and kind of discuss some ideas and see what people are thinking. What are people missing in their traditional consumer smart contracts, right? And what's missing? How can, like, what kind of technologies are they looking for? And I can kind of like point them in the right direction. It doesn't have to always be our products, but we can do a lot of stuff that can help you out and make you kind of like level up your builder game.
Yeah, I think that's been super useful. Maybe you can also like share the most important links and resources.
Oh, of course. At the bottom, like I think the most important resource is the one that I went through today to go through the developer journey. This is the Phala Fat Contract Starter Kit. The GitHub link should be, yeah. This is also a link to the starter kit as well. So that's kind of like the entry page for the developer to get up and running quick and get an understanding and get something deployed really fast. And then from there, they can start exploring all these different examples. So I would say go to the starter kit first, do the quick start, understand a little bit, and then from there you can go through all these examples here. This is hackathon resources. I put this last, but I created little resources here thing where you can kind of go through this, but I would say stick to the starter kit, because the starter kit's going to be the latest and greatest. This was like for multiple hackathons, so there could be some revisions to come, but yeah, so that's what I would say is the most important ones. And then where's the oh yeah, and Discord here. So join the Discord if you're really interested. Join the Discord, where we're always available to answer questions. If you have any technical problems, we'll definitely be quick to fix and help you out with whatever you need. If you have any questions, reach out to me. I'm pretty much like on all like social medias and Telegram and Discord. It's at #warlock. So you can find me online, and I'll answer. And if you have any things that you want to discuss as well, like I can help you with your ideas and help you with any kind of like integration as well.
All right. So thank you so much, Joshua from Phala. I think this has been super useful for all of the audience. You can also like listen at any time in the future, and then you can ask questions to Joshua on Discord. And I hope you learned a bit more about building cross-chain with Phala. And we run many of these like workshops, so please feel free to join our YouTube and Binance Live to join more of these sessions, and you won't miss any of these in the future. So like, once again, thank you so much for joining, and I hope you guys are building the next product that takes off and is one of the best products in the industry. So see you soon, guys, and thank you so much. Thank you so much, Joshua.
Bye-bye. Thank you. Oh, all good?
All good.
All right. Yeah. Thank you.